When the diameter of a pizza is increased by 2, the area increases by 44%. What was the area in square inches of the original pizza? Express your answer in terms of pi. So we have this old pizza that's a little bit smaller and this new pizza that's increasing by 44%. We know that the diameter has increased by 2 inches. Now there's a couple ways to go about this one. One is trying some whole numbers as our radius and seeing if we increase it by 1, since our diameter is increasing by 2, our radius increases by 1, we can try out some of these numbers, but it could get ugly. So I'm going to make it a little bit more abstract and see if it works. So we have our original old pizza and our new pizza. Well, our new pizza, we don't know a ton about that, so let's start there. We know that the area of a circle is pi r squared. And in this case, our new pizza is increasing the r, our original r, by 1, because our diameter is increasing by 2. So we have our pi r squared. And our old pizza, we have our pi r squared, keeping that our r is our original radius. But we know that our new pizza is 44% larger than our old. So that means that we are multiplying our old by 1.44. We're saying that we have 100% plus another 44% that will make it equal to our new one. Well, from this point it actually becomes pretty simple. We know that we can divide by pi on each side and get rid of that pi. And then what we have left is actually a bunch of square numbers. We have 1.44 r squared is equal to r plus 1 squared. So if we take the square root of each side, we find that, well, the square root of 1.44 is just 1.2. The square root of r squared is just r. And then on the other side, the square root of r plus 1 squared is just r plus 1. So when we get rid of the r on this side, we have 0.2r is equal to 1. If I multiply by 5, we just get r equals 5. So the radius of our original pizza is r equal to 5. So if we find the area of the original pizza, that means that we're doing pi times 5 squared. And they want it in terms of pi. So we can actually just leave it as 25 pi. And that's my answer, 25 pi. All right, let's keep going. 21. This is a pretty interesting one. So this one is also one that you could do a couple different ways, and I'm just going to show you kind of the more logical way to go about it. You can do it more abstractly. That's what I did originally, but you can do it more logically too. So let's try the more logic way of doing this. So it says if the numerator of a fraction is increased by 6, the value of the fraction will be increased by 1. Okay, let's take that part and just say we have this fraction x over y. And it's saying if I increase my numerator by 6, then I'm increasing the whole thing by 1. Which means that if I have x plus 6, then we know that our denominator has to be 6 in order to have that 1 be an extra 1 when we add the 6 on top. Because when we do this, if we have x over y plus 1, that 1 needs to be equal to 6 over 6, because we added that 6. So we know our denominator is 6. Now let's look at the second part of this. If the denominator of the original fraction is increased by 36, the value of the original fraction will decrease by 1. What is the original fraction? Express your answer as a common fraction. So now we're taking our original fraction, x over 6 6 because we know that denominator is 6. And we're increasing the denominator by 36 so that we now have this thing that's x over 42. Well, we know that when we do that, we lose something. So right here, we know that we lose 1 once we add a denominator of 36. So we know that it shouldn't go into those negative numbers and stay positive. So we know this x has to be greater than 6, right? Has to be greater than 6. Well, if we look at this, we can start plugging in some numbers. So let's say our x is 10. Let's say it's 10. And just start guessing and see if we can get a good estimate of where we might have to be, if we're too high or too low, something like that. So if we have our x as 10, and we know originally we had a denominator of 6, then this means that we have 1 and 4, 6. So by the end, we hope that ours is, we take away that 1, so it should be 4 6. Let's see if that works when we add 36 to the bottom. Then we have 10 over 42. Well, that's not quite right, but we're close, because if we simplified this, it would be close, but we're not quite there. All right, so let's try something else. I think we should go lower. And we do need to go lower. Because when we start to look at this, we see that, well, it has to do something with those 6s and 42s. And when we think about 6 and 42, well, we think of 7. Because 6 times 7 is 42. Well, let's try 7 and see what happens. So if we have original one of 7 over 6, well, that equals 1 over 1/6. So we're hoping that in the end we get something with 1/6. And when we do add that 36 to the denominator to get 42 in the denominator and 7 in the numerator, we do see that that is 1/6. So we've actually found it. We found that 7 over 6 is our original fraction. Okay, 7 over 6. And we basically just logicked our way through it to say that we have to have a denominator of 6. And because we added this 36 and got a new denominator of 42, it had to do with something with 6 and 42, which led us to 7. Okay, there are other ways to go about this that are a lot more abstract, but take quite a bit more time. So I'm not going to go through that right now because this is one of the ways that you can go through it. All right. So let's look at the next one. All right. We have the 80th term of an arithmetic sequence is twice the 30th term. If the first term of the sequence is 7, what is the 40th term? This one is an interesting one, and one that you can once again go about it a bunch of different ways, and this is how I did it. So I started setting up and saying, all right, my first term, well, I know that's 7. I'm going to start setting up. My first term is 7. And down the road, I see that my 30th is in there. And then a little bit farther down, I see my 80th. Okay? And what we know about these is that the 30th and the 80th are related in that the 80th is twice the 30th. So let's give some names to these. Let's call 30x and 82x. Makes logical sense. But what we don't know is how much we have to add in between each of these jumps to get to 30 and to get to 80. That's what we need to know. Since it's an arithmetic sequence, we know that we're adding things up to get to the next term. Well, if we add something to get the second, add something to get the third, all the way up to 30, it means between 1 and 30, we've made 29 jumps because we started with that 1 rather than 0. That's why we don't have 30 jumps. And they have to multiply by some number, because when we do repeated addition, all we're doing is multiplication. So if we have 29 jumps of some number, n, we can get to 30. And same idea going from 30 to 80. We have some number n that we're adding 50 times. We're adding up that n 50 times to get from 30 to 80. Well, this actually, it looks like we're going to have to do a systems of equations to figure this out. Because to get to our 30th term, to get to x, we know that we have 7 plus 29 of those n jumps to get to 30, our x. And when we want 2x, okay, if we didn't know anything about 30, we would say, well, I would need 7 plus, well, 79. Okay, we're going from here to here. I would need 79 jumps of this n to get to x. Well, we do have systems of equations, and it's going to help us. So in this situation, it's probably going to be easiest if we multiply this first one by a -2 to be able to cancel out this first column, this column here. But that means that we have to multiply by 2 everywhere. So let's do that. We have a -2x, we have a -58n, we have a -14. So this row is gone now, and we have this top row here, okay? So let's just add down. Well, -2x plus 2x is just 0. We have 79n minus 58n, which is just 21n. And we have -14 plus 7, which is just a -7. Okay, so now we have just one variable to work with, n, so we can figure out the space between each of the jumps that we have. So I'm going to rewrite it. We have -7 plus 21n equals 0. So that we have 21n equals 7. When we solve and divide by 21, we see that n equals 1/3. Well, it's great, because now we know that when we add, we know that we do 7 plus 1/3 plus 1/3 all the way. And our question is, what is the 40th term? Well, all that is saying is that from 1 to the 40th, somewhere in here, well, I make 39 of those jumps. 39 of these 1/3 jumps. So I start with my 7 plus 39 times 1/3. Well, 39 times 1/3 is just 13. Plus 7 gets me to 20. So my 40th number in this sequence is 20.